All right, let's go get ahead and get started this morning. Welcome everyone to Autodesk Virtual Academy. I'm Nigel Umbayek, working from my purple room today. And today we're going to be going over generative design. I'd like to first introduce one of my colleagues here at KETIV Technologies, Alex Alvarez. Alex, how's it going?
Pretty good, Nigel. Pretty good.
Good to hear. Alex, I know that you're probably lonely in the office. You went over there because internet connection and quiet. So hope you've been doing well during these times, and I'm really excited to see what you got to show us.
Awesome. Yeah, no, hopefully you were doing good. But yeah, only one in the office here. So it's nice and peaceful at the moment.
Absolutely. So you're going to go over some generative design. I know this has been a really hot topic over the last year with some of the improvements in the technology. You'll kind of give us a little bit of a background on what that means. If anyone has any questions at all during the webinar, definitely let us know. We'll go ahead and take care of that for you. And without further ado, I'll go ahead and pass it off to Alex. Just let me know when to fire off some of those polling questions.
Sounds good. Yeah, I'll let you know. Thanks for that introduction. So exactly like Nigel said, guys, we are going to be talking about generative design today. As always, we do like to start off with just a few learning objectives. But really, while you guys take a look at the objectives here, uh, for me, really, the my biggest goal and what I really want to showcase today is just how easy it is to work with generative design. Whether it's setting up a project, whether it's understanding kind of the general concepts for generative design, extremely easy to follow along. So I do want to go ahead and make sure that I showcase that. Not only that, I also want to kind of expose some of the stigmas around generative design. So typically, when you hear that term, you typically associate that with additive manufacturing. And to be frank, I don't blame you for that, or I don't blame you if you do think that, because again, if you take a look at some of the presentations out there, for the most part, you'll see the parts that are being generated. They look very organic. They look very alien in nature. And so again, don't blame you for thinking that it's just associated with additive manufacturing. But again, today I want to clear that up. I want to make sure that I point out to you guys that you can use traditional manufacturing methods with generative design. And again, going to show you guys how that works. You still are going to get some pretty organic parts, but again, that's just the nature of the software. And again, depending on those design criteria that you set forth in the technology or the software, it's going to dictate kind of what your design is going to look like in the final stages. So again, just a few objectives for today, right? Understand what the technology is, break down the role that generative design plays in product development, and really understand the foundational concepts behind the software or the tool. So again, we want to start off with what is generative design. And I think that the best way that I can put this is probably with a statement. And really, to me, generative design is a technology that's going to allow you to solve problems by defining objectives. That's probably the best way that I can see that technology. So again, generative design is going to allow you to solve problems by defining objectives. And this will probably make sense in the next slide here. But again, if we look down at the root of the tool, it does use artificial intelligence or machine learning. So it does have algorithms, and these algorithms, what they're designed or what they were based on off of is so that it mimics nature's design approach, right? So if you take a look at some of these results or some of these parts, they have a very organic nature to them. And again, that goes back to why they're generated in this way, because again, the algorithms that are driving these solutions are based off of nature's approach to how it designs. So again, if you guys were wondering why it shapes the parts in a specific manner, this is why. Again, while talking about results, we're not just getting one or two results out of the software. You can get anywhere from 30, 40, up to 100, maybe even more results than that. Again, what that's doing for you guys, it's on the business value end of this. It's giving your engineers to focus their time on maybe some more innovation, maybe focus on the outcomes of these solutions, instead of having to think of a design that's going to work for your components. All right, so again, taking a look at the generative design process, it's drastically different from this traditional approach in the sense that, the first phase or the iteration phase is not going to consist of maybe one or two different designs, right? So again, with generative design, what we're doing here is we're starting off with the objectives, our design criteria. So we know what kind of forces are going to be applied to the part. We know what kind of material we're going to be working with, what the manufacturing method is going to be like, or what manufacturing method you want to explore. And what generative is going to do, it's going to allow you, or it's going to allow us to generate hundreds of viable solutions that we may not have thought of, right? So again, that's you're getting these very organic parts, but at the same time, you're getting solutions that maybe you weren't thinking of, or maybe you weren't really thinking of a specific design strategy. One thing I do want to point out is that you don't have to take the solution that the software gives you, right? So what I mean by that is that you don't have to incorporate that actual part into your design. Take it for what it is, right? So use it as a reference part, use it as maybe even a starting point. So instead of again spending all those times and all those long hours kind of thinking of a design, let the software do that for you. And now you have a pretty solid starting point that's not only going to be manufacturable, but it's also going to be tested against some of the load conditions that you placed it. So again, this is going to evidently result in a shorter time to market. Again, so while we're reducing the time to market, much more valuable in that though is again exactly like I mentioned, you're going to get much more results. You're going to be maybe more on the innovative side, because again, you're going to get these very unique designs in nature, and again, designs that maybe you may not have thought of. So again, I'm going to pause here for a second. Nigel, if you want to go ahead and launch that poll, I'm just curious as to what you guys are kind of what your background for the viewers here. If you guys have manufacturing experience as well. So give you guys a second to go through the poll. If you can just answer some of those questions, that'd be great.
And while people are answering those in the back, Alex, do you want to see if there are any questions? I don't think there are, but if anyone has any, definitely reach out.
Yeah, so it doesn't look like we have any questions. Yeah, again, guys, this is going to be an open webinar. So if you guys have any questions, if you want to speak about something, we'll go ahead and let us know. We can unmute you as well. Again, this is supposed to be an interactive webinar here.
Cool. We'll give everyone another 30 seconds or so to answer the polls that Alex had put up there. But based on some of the preliminary results that we're getting, a lot of people are saying that some of this R&D stuff and the importance of bringing new products to market is up there.
Okay, awesome. Yeah, so we'll probably give it a few more seconds, but yeah. So again, especially with R&D and bringing new products to market. Again, especially the research and development, you want to make sure that not only your product is working and it's going to actually be working out in the actual field, but you want to make sure that you come up with something innovative at the same time. So again, hopefully generative design can get you those results, and again, based off of some of the design criteria that you guys select for it. Okay, so it looks like R&D and product to market, Nigel. It looks like those were the most important goals for most of the viewers.
Yeah, there were some people saying lightweighting as well, and it looks like it's definitely a mixture of additive and subtractive in terms of the design processes.
Awesome. Yeah, so that's good to see. And again, up to this point, we haven't had as many additive manufacturing customers or people who tend to go that route. But again, slowly making its way to a lot of businesses. And again, so with generative design, you now do have that kind of that plus or that addition to go with additive manufacturing. Again, to recap kind of just some of the things that we've talked about here. Again, the main value proposition with generative design is the design exploration, right? So you get hundreds of viable solutions that you can select from. And again, it's solutions that your engineer can select. So he's the one that's ultimately going to make the end decision. He's going to make the trade-offs between, are we going to go with something that's a little bit heavier, but it has a higher safety factor? Do we want to go lighter? And again, some of those trade-offs are going to be up to the engineer to decide. Again, not only do you get the hundreds of viable solutions, but you also get manufacturing intelligence built into the parts. You don't have to worry about sending this part out to manufacturing, getting it back, and then figuring out that, hey, maybe we can't machine a specific feature. Again, based off of the criteria that you set before actually running the part, that's going to dictate what kind of geometry is used to generate that part. And then obviously you don't want to just be stuck with a design and not be able to modify it or use it at the end of the cycle here. So at the end of generative design, you do get an editable CAD model that you can modify. You can rerun generative design if you want. If you want to even decrease the mass of it or the weight and kind of lightweight it, you can go into NetFab and start some latticing in there as well. So many different things that you can do, but the point is that you do get CAD geometry that you can export out to your CAD software. With that being said, again, you're not just limited to working with Fusion 360 models. Again, want to make sure that I point out, especially in the AVAs, there's a lot of Inventor users. If you have Inventor, you can use generative design, but again, you want to make sure that you have Fusion 360. So not only do you can import a part into Fusion 360. If you have Fusion Team, you can also use the AnyCAD technology that's built into Fusion 360 and have that link between your Inventor parts and the Fusion model. So again, not limited to just working inside of Fusion 360 or working with Fusion 360 components. You can use a broad range of different CAD formats here. And then, as many of you guys know, there has been a partnership with Autodesk and Ansys. Again, why is this a big deal? Well, because a lot of companies, especially if you're aerospace or if you're in the government sector, you might already have some standards in place in terms of using Ansys for your simulation. Again, Autodesk realized that they didn't want to steer customers away from any of that. So now what you can do, and again, I don't have an example today, but hopefully in the upcoming webinars, we can kind of show this workflow a little bit more in depth. But if you have Ansys Mechanical installed on your desktop and Fusion 360, as soon as you run a generative design part, you are going to get this little icon here that you see here. And you're going to be able to export out to Ansys Mechanical. So again, you're going to get all your load conditions, your materials are going to populate as well. And it's going to, you can use Ansys Mechanical to further validate some of those results. Again, those are just because there's probably standards in place that your company has if you're using Ansys. So again, they didn't want to steer you away from that and prevent that from happening. Again, you can either use Fusion 360 simulation capabilities. Again, if you have Ansys, you can use Ansys as well. So with that said, again, I'm going to go ahead and jump into the live demo. Let's go ahead and just take a look at how you set up some of these components. So this is the part that I'm going to be working on. So again, if you take a look at what it is, if you guys are familiar with it, it's essentially just a stamping die or stamping tool. So if you can think of, we're going to put a thin sheet metal part here or a plate. Tool's going to come down, it's going to stamp it, and then we're going to kind of continue the process. Again, didn't want to focus on aerospace components, didn't want to focus on automotive. This is going to be an industrial machinery component. And it's an assembly as well. So that's another thing that I want to relay to you guys. You're not just limited to working with a single part. If you have an assembly that maybe you want to start consolidating some of the parts, maybe you want to figure out if there's something that that you can eliminate or maybe combine some of the components. Use generative design. Use that as as an idea of how you can maybe reduce the cost of production for some of those components that you guys currently have. But anyway, so this is what we're going to be looking at. Specifically, we're going to be looking at this frame. Again, to begin with, it's not really the best frame to begin with, to be honest with you guys. But nonetheless, we're going to go ahead and see what we can do with it. Let's assume too that before generative design, we had a few designers spend maybe a couple weeks designing some of the parts, or maybe designing a second iteration of this frame. And then we have this cast forming. So this is something that's a little bit more traditional, right? Especially if you're gonna do a large quantity run of these, you're gonna go with the casting method. If you maybe aren't gonna do as many, maybe you want to go ahead and do a welded version of it, right? Depending on kind of the production run that you're gonna be doing. So these are the two frames that our engineers have come up with. Um, what I want to introduce today is how do we use generative design then to apply a new design, or how do we generate new design ideas for this specific frame. And again, if you guys are brand new to Fusion 360 or you probably haven't seen it before, this is exactly what you get, right? So again, this is the user interface. The workflow that we're going to follow is very linear, so it's going to always be typically going to be from left to right, kind of depending on the environment that you're on. But again, I'm going to go through the data panel here just real quick to show you guys some of its capabilities. But again, if it's a cloud-based software, and kind of the power with that is the collaboration aspects of it. So you'll see here that we have a People's tab. If you want to share this project with anyone, you don't need to export it out to Dropbox or to OneDrive. You automatically can invite other Fusion 360 users to it, and they're going to have access to all of the different components that you have here. So again, very nice, very easy to share projects and to share data across your teams. So again, with this design created, let's go ahead and jump right into generative design. All right, so we're gonna go ahead and jump right into it. Our toolbar is gonna change, and I'll talk a little bit about what we have going on here. But again, if you really break down generative design to its core, like I said, all it's really interested in, or really all it's looking for, are going to be starting shapes, obstacle geometry, and if you need to preserve any regions, right? So if we take a look here, I'm gonna go ahead and start shutting some of this down just so we can take a look at what we have going on. You still need to understand your component, right? You still need to understand the assembly. If we go back to the assembly design, you need to understand what's going to happen, the loading conditions that are going to take place as the tool is coming down and stamping the plate. If we take a look here, we see that it is going to be fixed on this bottom plate here. As the tool is going to come down and stamp, so there's a force going up. There's some sort of distance associated here with the center of it and then the front of the plate. So you're going to have a moment on either where the bolts are going to be attached or on this face here. So we're going to simplify. We're going to say that there's going to be a moment on this face just for today. But again, you can get as extensive or intensive as you want in this scenario. But again, point being, you do need to understand your assembly and how it's going to function, or how these components are going to interact. It's not going to be as easy as just plug and play. So like I said, you want to make sure that you get that or those points kind of figured out before jumping into the software. So again, generative design, we're going to go jump right into it. And like I said, so you want to go ahead and preserve regions. You want to understand what you want to preserve in the first place. We know that the mounting plate has to be there at the very bottom. We know that the mounting plate at the top has to be there as well, because that's where our tool is going to be bolted onto. So that's what we want to preserve in the first place. And again, guys, I'm going to go through this. This is already a completed model, but I'm going to explain to you guys why at the end why I'm doing this. So again, preserve regions. This is going to be what we're going to want to make sure that we keep. Want to make sure that the software doesn't really modify any of these parts here. And then all of that's going to be taken care of inside of this edit model dialog box, right? So if we take a look at it, it looks exactly or very similar to kind of the design space that we had inside of the environment here. What's nice about this, though, is that this geometry is only going to be associated with generative design, right? So even though you create some of this crazy geometry, it's only going to be associated with generative design environments. So again, as soon as you go back into your regular design space, you're not going to see any of the kind of the reference bodies that you created here. Nice thing about this is that you actually have tools that allow you to simplify your entire assembly. So if we break it down, again, we have preserved regions, right? So we have these two plates. If we left those two plates without any additional information, what the software may or may not try to do is create geometry maybe around this region, right? Again, if we go back to our original design, we have material here, we have parts here that we don't want to touch. We don't want any sort of material here. So that leads us to the next part of the kind of the steps here for generative design is you want to create some sort of material that's going to be obstacle geometry. right? So that obstacle geometry is essentially going to tell the software, hey, don't create material around this area. Doesn't have to be perfect. You know, as you see here, you could have used the bodies that were already there, or you could have actually created something similar to that. But what we did here is we just did a rectangular shape, right? So we just did a few boxes here just so that the software knows to stay away from that. Kind of some additional features here that I like is the bolted connections here, if you can think of them as bolted connections. If you select it, you'll see kind of what I'm talking about, but it's saying, okay, what's going to be the start of the shaft, end of the shaft? Are you going to have a bolt head on it, tool clearance, right? You'll see some of those parts down here at the very bottom. I'm going to go ahead and just bring this all the way forward so you guys can see what I started off with. And so this is our initial design. Again, we don't have any of these components removed. After a while, we're going to go ahead and remove some of these components, right? So then we grounded some, removed a few more components. And really what we removed is some of the hardware. So generative design doesn't need the bolts. It doesn't need any of that, the hardware included there to be able to run correctly. And then what we did next is we actually did a sketch. So again, that sketch is going to be referencing essentially the perimeter of where we want to stay away from, right? So again, there's a sketch, and then we did an extrusion. We set it so that it's, again, encompassing kind of the length of the part that we had. We went ahead and we cleaned up some of the edges here. And then for this next one, we went ahead and we did that connector obstacle, right? So again, if we right click on this, we'll go to edit feature. We can see kind of the settings that we had. Again, and what we're doing here, you know, it looks a little crazy, it looks a little interesting, but essentially, if you think about it, what we're doing is we're telling the software, don't create material along any of this region, right? We want to be able to get into this part. We want to be able to make sure that we have access to this bolt here. Make sure that you don't create geometry anywhere along this geometry here. And then again, did that a few times. So again, it is a very tedious process. And not tedious in the sense that it's hard to do, but there's a lot of repetition that goes along with generative design, especially if you have something you know, that's kind of complicated. You have a complex assembly. So again, the main goal here is just break it down to obstacle geometry and geometry that you want to keep. Right. So again, that was our preserved geometry. Our obstacle geometry is going to be set in place here. Right, so you can kind of see where we want the material to stay away from. You're going to have a starting shape. I'm going to turn this. You can kind of see the starting shape here. Again, this starting shape, it's not necessary. So again, if you don't have a starting shape, we can actually run this design software, or you know, we can run the tool kind of as it is now. That's completely fine. With starting shapes, though, what it's going to do is if you can think of it, it's going to give the software kind of a nudge into the direction that you think is best suited for this product. Again, it's not necessary. You can create viable results without having a starting shape. But if you already have a starting shape, just go ahead and use it and see if you know, see if you can kind of nudge the software in that direction. Let me go ahead and pull up kind of an example here. If you take a look at this phone holder, you'll see some of these solutions, you know, they're drastically different, and that was again because we used different starting shapes for them. One thing about generative design is if you don't have a starting shape, or if you use, you know, something standard, you kind of let the software choose the designs. For the most part, it's going to try to replicate the designs across the solutions, right? So I mean, granted that you have the similar material and the manufacturing methods, but if you provide different starting shapes for it, this is kind of what you're going to end up with, right? So again, different solutions that you can explore based off of kind of your design criteria. So that's how starting shapes play a role here, just to give you guys an idea of it. Again, not necessary, but again, if you guys do have it, it's always helpful. One way that, again, I want to point out to the obstacle geometry, one way that you can use it, or that I have used it in the past, is if you want to limit the part to a specific size. If you know, maybe you knew that you had a piece of stock that you couldn't go past a certain dimension, or maybe you don't want to go past a specific size, you can use obstacle geometry to limit that. What you would have to do though is create essentially a hollow box around this, or a hollow box around the area that you want to kind of stay within. And that, if you can think of it, is going to give it a boundary to, that the software is going to stay in. Again, it depends on it depends on what you're looking for, but typically you don't want to do that, because again, you want to give the software the freedom that it needs to design or to explore some of these different results. So again, that was the edit model. We talked about the design space. So again, preserved geometry, obstacle geometry, design conditions. So this is again something that we're all familiar with. What kind of constraints are you going to be applying? The load conditions. So again, we have a moment applied on this front face. I'm going to go ahead and hide this obstacle geometry. Moment applied on this front face, and then we fixed this bottom plate. Again, we could have done this a little bit more realistic. We could have fixed the bolt holes here, right? And then maybe had the head of the bolt here, so have a cylindrical surface that was going to be fixed as well, so that it actually shows like if it was a bolted part or a bolted assembly. Again, wanted to keep this simple just to make sure that we were able to run the simulation on time. But again, those were your conditions, and that's kind of the next step after you do some of the prep work here for your model. And then we start getting into the actual design criteria for generative design, right? So again, starting off with your objectives, what are you trying to do exactly with this part? Are you trying to minimize the mass? Or are you trying to maximize stiffness? Again, if you select maximize stiffness, you do need to give it a mass target based off of that selection, right? So again, minimize mass, safety factors. So again, depending on what criteria you want to hit here is kind of what's going to dictate some of your values. And again, like I was mentioning, you do have the manufacturing criteria as well. So again, starting off with production volume, how many pieces are you going to run? If this is going to be just a one-off part that you want to see, a unique design for, set that to be one. This does take into account the cost for it. So if you are going to be milling this specific component, based off of the actual stock cost and kind of the time that it takes to do some of the manufacturing for that part, it is going to give you a cost associated with that part. So just keep that in mind. That's why we get some of these options in here. You do have the cost analysis that's kind of built into some of these parts. Again, we have a few options. Unrestricted, meaning that you're not essentially restricted to any kind of manufacturing method. So this is going to give you probably the most unique models in here. If that's what you're after, by all means, go ahead and select that. Just keep in mind that the more options or the more different configurations that you have here, the more time you're going to add to the simulation. If you have additive capabilities, right? So what's the overhang angle? What's the maximum that the machine can go up to without needing support material on the bottom? You can say your minimum thickness here as well. So again, these are all kind of options that you guys should be familiar with if you have this kind of manufacturing capability. What's nice about this too is that you can set different configurations, right? So notice that we have 2 3-axis configurations here. The only difference between these is what the tool direction is going to be in, right? So essentially what you're telling the software here is that you can actually rotate. So if you think about it, configuration 1 has access, or you have the ability to maybe have 2 work setups, right? So you have a setup on the x-axis, you have a setup on the z-axis, so you can rotate the part, and now you have different setups for that configuration. Configuration 2, you're essentially giving the freedom to the software, saying, okay, we can go ahead and give it X number of setups, or 3, 4 different number of setups, just so that we have access to all, essentially all parts or directions of the component that gets created. And then again, specifying tool diameter, kind of the head diameter here as well. So this is all going to be associated with the tools that you have available, and then some of the machine values in here as well. If you have 2-axis cutting, so if you have laser jet or plasma water jet, you can go ahead and define that in here as well. And then obviously if you have die casting, or if you want to see some die casted parts, where is the ejection direction going to be, and then again just some additional parameters in here. So again, don't want to get too much in depth into some of these, and again we'll kind of explain why here at the end. But these are all different settings that are going to give you different results, right? So that's one thing I do want to point out. If you do start changing some of these default settings, it is going to start kind of incorporating different results at the end of the simulation. So I'm going to go ahead and cancel this. Again, you want to make sure that you specify your materials, right? So what kind of materials do you want to analyze? If you take a look here, we have a few different materials. So we have stainless steel, aluminum, right? And then we have cast iron for that die cast option as well. Now, one thing you do want to make sure before actually running the simulation is launch the previewer. So this is going to give you a general idea of whether or not you set up your part correctly. If you see material going into maybe some of the areas that it wasn't supposed to, that's a good indication to you that you need to go back into the actual model and make some changes, or maybe add some more obstacle geometry, right? So again, just be aware of that when you're working with this technology is take advantage of the previewer. Again, it's not going to give you the final result, but it is going to give you a pretty good indication of which direction it's heading. And then after that, you want to go ahead and generate. I'm going to go ahead and see if we have results here. Go ahead and open this one. Yeah, neither. Okay, so sometimes it happens, right, when we change the actual model here. So as I was changing some of the settings or some of the options, it did change, or it felt like something changed. So again, some of the results weren't necessarily there. So let me see if I have the part here just to show you guys the final part that we came up with. So I'm going to go ahead and pull up this part. Okay, so this is the part that we came up with, and this is actually, believe it or not, a 5-axis part. Um, and so again, what I want to go ahead and highlight here is take this part as it is, right? So again, if this is something that you're looking for, so again, if you want to maybe disrupt the market, so this is your industry and you want to be market innovators and maybe you want to come up with a new product, by all means, go ahead and run with this part, right? Maybe make a few more changes if you want to. But what you can do with this one is actually look at the part, look at the design that the software came up with, and then come up with your own design. If we take a look at some of the section analysis here, right? As you're going through the part, you'll see that it has, somewhat of an I-beam structure here. So what you can do is, again, come up with your own design, use this as, maybe different ideas that you can go ahead and come up with. If you take a look at some of the components here that are connecting the plate with the actual body of the part, it doesn't have material all around it because, again, it's only focusing more on the kind of the loading conditions, or where most of the loading condition is going to happen or take place. So again, use that to your advantage, and now you can come up with something that's a little bit more consistent at this, right? But again, if you did want to create this part, this is the part that you can definitely use, or you can create on a 5-axis machine. It might just take a little bit longer, right? If you want to do something with a little bit more traditional manufacturing standards, maybe you only have a 3-axis machine available. Maybe you would want to just use this part, or use this part as a reference, and then create something that's a little bit easier to manufacture, right? So let me see why we don't have that. I did want to show the explore results here, so let me just double check one. So I'll go ahead and generate the study just for now, just so that we at least go to the explore results page and talk about it just for a second. Okay. So we're not going to see any results yet because again, once we made that change, software thought that there was a change in the actual modeling, so it wanted to run the results again. But as you're going through this, again, what you're going to be seeing up here, it's slightly a bit more in terms of, or at least a little bit more information in terms of what you're getting. When you're seeing some of the results pop up, you have a few different options that you can select from. So you can do a thumbnail view. So again, just seeing the actual image of the parts kind of pop up here. What you can start doing is you can start grouping by similarities. So if you start seeing parts or you start seeing multiple parts that have some sort of similarities in there, you can actually start grouping them and again start seeing some of the features that are going to be a little bit more consistent or more standard across these different designs. You can take a look at some of the properties, right? So things such as mass, cost. You have different properties that you can explore here. You have a scatter plot view. So again, you can plot the different parts based off of if you want to plot based off of weight or mass, plot based off of safety factors. So you have different things that you can plot the parts, and again, that's going to show you just a different results based off of what you select. Again, filters. Again, like I mentioned, you do have different results that you can select from, or you do get hundreds of results usually. So sometimes it's nice to use some of these filters and take advantage of kind of what's going on here. And then, like I said, once you do have the part created, you can go ahead and export that part. And if we take a look here, you can go ahead and right click on this. You can say edit, and now you have geometry that you can manipulate, right? So manipulate the geometry a little bit. You can rerun simulation studies. Like I said, you can actually run this in Autodesk or Ansys Mechanical if you have Ansys installed on your computer as well. The software is going to pick that up. So just a couple of things to note there. Again, wanted to show you kind of the full breadth of the Explore web the dialog page here, but again, unfortunately, we don't have the results generated. But again, this is kind of the end result that I was getting to. And okay, so with that, I think we can go into some of the questions.
Yep. So let's go ahead and take a look at some of those questions, Alex. First one. So the first question is like, now that generative design is aimed for 3D printing and CNC production, do you have a plan to introduce generative design for injection molding? For example, combine it with mold flow for plastic parts manufacturing optimization. So that's definitely something that I haven't heard too much about before, but we'll certainly pass that information over. I don't see anything in the roadmap stating any generative design for mold, injection molding, specifically mold flow application.
Mm-hmm.
I know that the design, the manufacturing process is completely different, and it has all of its very specific intricacies. So, yeah, that'd be something to bring up to some of those people on the advanced manufacturing team at Autodesk and see if you had anything to respond to.
Yeah. Yeah, and you know that you bring up a good point because again, the die casting is actually an option that again fairly recent. So they just incorporated that into the manufacturing methods for Fusion. Exactly like you said, I haven't seen anything around plastic injection parts or plastic injection molded parts. But what we can do is maybe even do a webinar maybe on a generative design part and see how it interacts with mold flow, right? Because we do have Nikhil actually is pretty familiar with mold flow, and he uses that day in day out, so we can see how those two interact and see what we can do around those two.
And then another question in regards to Inventor. How do you envision the workflow if you use Inventor mainly for your modeling, using some of the generative design workflows in Fusion?
Yeah, so that's a good question. So Fusion Team actually has connectivity with Vault. Again, we've done. I want to say there's a webinar on interoperability with Vault and Fusion Team. But essentially, what you would do is it kind of follow along what that's doing, right? So again, use your parts, use Fusion Team, save your parts to Fusion Team, and essentially what that's going to do is you're essentially saving your parts into a Fusion 360 data panel, right? Because again, Fusion Team does have connection with Fusion 360. So that's how you would connect the two, and then obviously from there you can work with generative design exactly as you would if you were on just a standalone.
Yep, and you can do that same thing with Vault as well, right? So there is a Fusion Team connector within Vault Pro that'll allow you to, you know, kind of go back and forth and make that process a little bit easier, because Fusion Team is like directly accessible from within Fusion 360. Hopefully I said that correctly.
Yeah.
My fusions.
Yeah, no, yeah. So as long as you have Fusion Team, you can connect Vault to Fusion 360 technically, right? Because again, you have that kind of that bridge with Fusion
Yep.
Team.
Exactly. And so let's see what else we got here. How did you create the boundary to ensure the design would be symmetrical?
Yeah, so I think I did see that question. I did create that boundary, that obstacle geometry on the midplane. Again, as of right now, the software aims to be to have some sort of symmetry, but you don't have an explicit option there that tells the software to be or to generate a symmetrical model. So again, that's one thing to take note of. It looks symmetrical. I don't think it was quite symmetrical, but the software does try to aim to be as symmetrical as possible. But I did create that obstacle geometry on the midplane.
Cool. Let's see. Can you use Fusion 360 for dynamic simulations to get loads? For example, generative design working with the dynamic load. If I have a reciprocating mechanism of a vibrator, can I optimize that using generative design?
So that's probably something that we will have to kind of discuss offline. Right now, the software only has a few different studies that it can generate. What you can do though is you can generate a part using generative design and then bring it into the simulation environment again, and then run an additional study on it. Again, kind of depending on what exactly you're looking for, that's something that we can communicate. But again, you can always import your generative design part back into the simulation study, and then run a different simulation study analysis on it, right? Just to make sure that it does satisfy that.
Yep. Absolutely. Thanks again, Alex. And thanks again, everybody, for joining us today. We'll see you next week. Adios, Alex. Take it easy.
Yep, you too.